So welcome to this class. In this session, we are going to analyze an ellipse whose major axis is parallel to the y-axis and center is h, k. That's the same as saying analysis of vertical ellipse shifted away from the origin. So analysis. Of vertical ellipse so its center is h, k, and then axis, major axis, parallel to y-axis. So let's draw the sketch. And then let this be the line x equals to h. And then this this be the ellipse. So this to be the vertex. This is the center. One another focus here, another focus here. And then let this the lattice rectangle. And then, so and then we label this one as our V1, F1, this is center, F2, V2. So let's call this one M1, M2, N1, N2. This B1, B2. So what we know is that the coordinates of the center is h, k. Distance from the center to one of the vertices is one of the vertices is b units. So this is b units, this also b units. And distance from the center to the foci on the focus is c units. Distance from the center to the vertices is a units. So we can do this. And just extend these lines to the axis so that we are able to read the coordinates with ease. So because this is HK, so this must be K, this must be H. And then also join M1, N1, and then put on the x-axis, join M2, N2, and then join B1, B2, join B1 to the B1 and B2 to the x-axis. This is what we have. So because we know that distance from C to F1 is C units, then this must be K plus C units. And distance from C center to the vertex is A units. So this must be K plus A. Distance from C to F is C units. So this must be K minus C. And then this one is, you read this coordinates here. That must give us K minus A. And we also know that the distance from F to these ends of the lattice rectangle is B squared over A. So this is also B squared over A. So B squared over A, B squared over A. So I'm not deriving how we're getting B squared over A in this session. If you don't know how it comes about, please watch the previous videos. So this is H. Now if this is B squared over A, then this must be H plus B squared over A. And then this other one here must be this B units. So H plus B. And then this must be H minus B. And this must be H minus B squared over A. So the first thing, equation of this vertical ellipse is given by y minus k squared over a squared plus x minus h squared over b squared equals to 1, and a squared minus c squared is given by b squared, and always a is greater than c. So that's the first thing. And so V1, coordinates of the V1, from this one, we see this is H and then K plus A. So H comma K plus A. That's the first vertex. And the second vertex, V2, is H comma K minus A. So those are the coordinates of the vertices. Now, let's go to the core vertices. So B1 will be given now. This way I have B1. So X value is H plus B. So H plus B, comma, Y value is K. So H plus B, comma, K. And B2, you see here, X value is H minus B, then Y is K. So H minus B, Y is K. And then let's go to the foci. So foci, F1, this point here, value of X is H, value of Y is K plus C. So that's what we have. And then F2, this X is H, Y is K minus, this is K minus C, this value here. So K minus C. And then M1, if you were to get M1, coordinates M1. So here we have H plus B squared over A, comma, and then this is K plus C. This way we have the y value. And then M2 will be given by this x value is h minus b squared over a, comma, k plus c. And then when we go to the N1, this point here, x value is h plus b squared over 2 over a, comma, we have y value is k minus c. And then N2 will be given by this point here, h minus b squared over a, comma, y value is k minus c. And then eccentricity remains to be c over a, length of major axis remains to be distance from V1 to V2, which is just 2a, length of minor axis remains to be distance from the co-vertices, between the co-vertices, B1, B2, which is 2b. And then that's the analysis of that given ellipse. So thank you.